Hello guys, and welcome to the first IIT JEE Foundation Quiz of our series of quizzes wherein we will be testing you on certain basic fundamentals. You know, as the name foundation suggests, what does it actually mean? It actually means the fact that there are certain concepts that you have learnt in your 9th and 10th physics concepts, of course, because the series is all about physics, and you never know, when you start studying in your 11th and 12th, what you will realize is the fact that there are so many things, there are so many concepts here and there which are slightly built on top of what you have already studied in 9th and 10th, and sometimes you'll also feel that certain topics are somewhat contradicting what you have studied in your 9th and 10th. So it's extremely important for you to have fundamental clarity on all your 9th and 10th concepts, because if there is a difference in what you study in 11th and 12th, especially in subjects like chemistry, physics, that doesn't happen a lot, you should be able to identify the difference, that okay, it's from here that this is differing from what you studied in 9th and 10th, right? And if there is something which is being built on top of what you have already studied, you need to have enough conceptual understanding to go hand in hand with that as well. So this series of quizzes, which more often than not, I have personally designed it, right? There are questions which will seem easy to you. I'm telling you, there are questions which will seem easy to you, but there are some questions which are going to really test you. So make sure you read every question before you answer it properly. It's about 30 seconds of time which you will get to answer every question. Be honest with yourself. Don't try googling any question, because all these questions are handwritten, right? I've not picked it up from anywhere. You won't mostly find any of them on Google. So yeah, be very, very attentive. And as I'm telling you, questions will seem easy, but yeah, they are meant to more or less trap you. So let me start putting the first question on. So I guess we are ready with the questions now. Sorry for the delay. I'll just be triggering the first question any moment. I just wait for you guys to be ready for the first question. So here comes the first question on your screen. So the first question goes like this. This should be a simpler one for you guys. Which property of a body does Newton's first law address? So I think that's all as far as time is concerned. Let us look at what people have answered. Okay, as expected, most of the people have answered mass as the answer, right? And few people have answered inertia. Some people have answered speed. None of them have answered geometry. That's good. I told you, think before you answer. The actual answer to the question is option B, inertia. It's not mass. I know mass and inertia are very close to each other, but as far as the answer to this question is concerned, like the exact property that Newton's first law addresses, it's not mass, it is inertia, right? The inertia of a body, the ability of a body or the resistance of a body to change its state of motion. That's actually inertia and not mass. So let's move on to the next question now. Which of the following justifies Newton's second law the best? Relationship between speed and momentum, relation between force and speed, relation between momentum and force, relation between rate of change of momentum and force. Very close options, but again, as I'm telling you, they are close for a reason. It's to test how closely have you followed the properties in your 11th and 12th. So I'm just waiting for you guys to in your 10th actually. 11th and 12th is yet to come. So I'm waiting for you guys to answer this. Let's see what most people are going to respond as far as this particular question is concerned. I'm not sure if you guys are able to see the question. Still waiting for you guys to respond. So I'm trying to display it from here, but oh, after a lot of time it's finally here. Okay, yeah. So now you can attempt it. I've got some grace time, I guess. Which of the following justifies Newton's second law the best? Read the options carefully. They are pretty close to each other. But yeah, there's just one correct answer. And as you saw, most of you got stumped in the first question. This has to be spot on. So it's about 3 seconds to go. Let's see what most people have responded. Relationship between force and speed. Okay, 17% people say relationship between speed and momentum, between force and speed. Okay, that's not really right. The actual answer to this question is relationship between rate of change of momentum and force. I think only 17% people have answered this right. So as you can see, options seem close to each other, but there is definitely a lot of conceptual clarity that's required to answer such questions, because if you read the Newton's second law properly, it's force is equal to change of momentum by time, change by time, anything. Whenever you hear the word rate in physics, it means time, right? So the momentum by time is equal to force. That's change in momentum by time. That's called as rate of change of momentum, right? So that's the trick here. I think we are comfortable to move on to the next question. Yeah. So let's quickly move to the next one. I've been trying to display it. Yeah. Which of the following has the greatest momentum? Now this question is more like common sense. Do not try to involve a lot of mathematics here. Think of what you have felt about momentum. How have you perceived momentum? Momentum is quantity of motion. Where there is greater motion, right? Heavy motion, fast motion, like a lot of motion. That's called momentum. Which of these things in which of these options do you think there is a greater amount of motion? I hope, okay. This is a better response. At least 50% of the people have answered option A, which happens to be the correct option. Elephant running at 10 meters per second. Some people are tempted to go for option B, the other half, which is ant running at 100 meters per second. That's not right, because speed is multiplied by 10 times, but an elephant is like lakhs and lakhs of times more heavier than an ant, right? Not just 10 times. So that speed of an ant is more, but mass of an element is much, much greater compared to an ant, right? So if you look at the net quantity of motion, momentum depends on mass as well as velocity. Together, the product has to be very high. So that's the highest in option A, and that's the reason why that is the answer. So now we are ready to move to the next question. So yeah, here's the next one. In Newton's third law, the action-reaction pair are applicable on which of the following? Well, a very, very important question. Again, a very, very fundamental question. You'll be coming across this in your 11th as well. When you study Newton's laws of motion, this exact question will again come. But this is just to test whether you have understood it fundamentally or not in your 9th and 10th itself. So read the options carefully and then attempt, right? They are very close, I agree. But yeah. Let's see what is to come. The statistics are here. Oh, that's great. Finally, more number of people have answered option B, 80% of the people. That's good. That happens to be the correct answer also, right? On different bodies in a pair of two bodies, right? The action and reaction happens on two different bodies. It doesn't happen on the same body, right? You push a wall. Wall is an object, you are an object. You are pushing the wall, that's action. The wall is pushing you, reaction. The reaction is on you. The action is on the wall. So action-reaction pair happens on two different bodies, right? Not the same body. So that's the reason why only option B is right. And I'm happy 80% of the people have answered it. Let's move on to the next one. We are good to go. These questions are all handcrafted, let me tell you. They are absolute gold. They're absolute gold. Do mass and weight represent the same physical quantity of a body? Well, this is again tricky. This is the reason why, or close to this is the reason why some people got the first question wrong. So let me see how many people know the answer to this, whether they are same, whether they are similar, whether they are quite different from each other. All options again are close by. It's a very interesting attempt. Let's see. Let's wait for the statistics. Here they are. Okay, again some people got trapped in this. Okay, that's good. Half of the people have said they are similar in terms of how they are related, but they are not the same, and that happens to be the answer. Weight is mass. If you know the formulas, mass is m, weight is mg, right? M into g, that's weight, that's force, right? Mass is just the quantity. Weight is more like the effect of that quantity. Like when you measure yourself on a weighing scale, it's the weight which you see, which is calibrated in the form of mass, but it's actually the weight in newtons that you see. So weight is in newtons, mass is in kgs, right? They are similar, they are not the same thing. That's for the half of the people who have attempted option A. They are not the same thing. So yeah, let's move on to the next one. I guess we are good to go. Question number 6 coming on your screen. this is going to be quite simple attempt. Even if you have studied the basic definitions of what a scalar and a vector is, you should be able to attempt this. What is the difference between a vector and a scalar quantity? Right? Just from the definition of the textbook. You don't even have to, think a lot about this to answer a question like this, right? Just from your textbook. So trust your instincts, trust your textbook definition, just go ahead with that. That's how simple this particular question is. I hope to see 100% of the people getting this right. Well, I'm not really able to view the statistics of this question. NaN%. I think everybody has got this right, I hope, because it's quite simple, and actually option A is the answer. Vector has both magnitude and direction, while a scalar only has a magnitude. A scalar doesn't have to do anything with the direction. For instance, your speed and velocity. Speed, you just care about the magnitude. You just care about how fast an object is. You don't care about which direction it's moving in, right? So speed is a scalar. Whereas velocity, you care both about the quantity and the direction in which velocity occurs, right? The direction in which a car is moving, not just how fast, but where it's moving. That's why in such quantities, magnitude and direction both become significant, and that's why velocity is a vector. So yeah, this should be a simple attempt. Let's move on to the next one. Question number 7, shortly coming on your screen. Let's see how many people get this one right. Again, this is going to be very interesting. From your textbook, slightly tricky, I don't know, I'm not sure. For some people it shouldn't be. But again, yeah, as you can see, most of these questions are original. Which of the following quantities is properly known as a human's friend and enemy at the same time? If you would have focused a little in your 9th and 10th, you should have seen this particular term, this particular question. Of these 4 quantities, there is one quantity. In fact, almost every physical quantity is a human's friend and sometimes an enemy at the same time, but this particular quantity is very evidently a friend and a human in a lot of instances. So that is the reason why the answer to the question is friction. I don't know how many people have attempted this again. So yeah, the answer to the question is option C, friction, right? Again, you could argue that okay, energy is also a human's friend and an enemy at the same time. Like a lot of energy can create destruction. Energy can give rise to work and all, with which humans can do work. So it's a friend and enemy. Like you can explain, but the question says most popularly. Why did I use the word popularly? Because it was mentioned in your textbook. Humans friend or foe, friction, right? If some of you are able to recall this. So yeah, this question done. Let's move on to the next one. Answer to the question was friction. Shortly coming up on your screen is the 8th question. Well, this is going to be very, very interesting, this particular question, right? It's some of you might not even have thought about this possibility, but yeah, this is going to teach you something for sure. Is it possible for us to measure different kinetic energies of a single body which has a fixed mass and fixed velocity? So you guys know kinetic energy is equal to half mv square. If mass is fixed, v is fixed, can a body which is moving with a fixed mass and velocity, if I measure its kinetic energy and other person measures its kinetic energy, can they be different in any scenario, or they compulsorily have to be same? That's the question here. It's a very, very interesting question. Option A, yes, it is possible. It is possible for a body to have different kinetic energies. How is it possible? Now I'll take some time to explain this. Okay, so you are moving in a bus, let's say, and a person is moving with some 10 meter per second. Okay, so there are 3 people. First person having mass m moving with 10 meter per second. Somebody is staying on the ground and looking at that person. He will see, the person on the ground will see that that guy is moving with 10 meter per second. So he will see half into m into 10 square kinetic energy, right? And let's say I'm the second person who's sitting in a bus. The bus is also moving with 10 meter per second. So it's like, now the person in front of me is moving with 10 meter per second. The bus is also moving with 10 meter per second. So both are moving together. If you can see me, both are moving together. So this guy will see that this guy is at rest. So even though this guy was moving, this guy will feel that he has zero kinetic energy. So you will learn this in Newton's laws of motion. Kinetic energy depends on the frame of reference. Where are you observing it from? Are you observing a body from a moving body, or are you observing a body from the ground, right? Different frame of references can give different kinetic energy. So that's the reason why it is possible for us to measure different kinetic energies for a body having a fixed mass and a fixed velocity. So yeah, that was a very interesting take. Let's move on to the next question. Coming up on your screen. Which of the following laws explains best as to why a cricketer takes his hands? I remember I had read this particular concept in this book called S. Chand, Lakmeet Singh and Manjeet Kaur. That's where I had read this particular concept, and that's how I framed this particular question from there in my own words. So yeah, you have to be again more or less thorough to answer this. It comes from your 9th class mechanics. So yeah, just think about it. Think about what every Newton's law says, right? And then try to connect that with your this scenario wherein a cricketer is taking a ball. When he catches, he takes his hands back. Otherwise, it will pain. The hands will pain. Why? Which law is responsible for that? Think. So yeah, the answer to the question is Newton's second law. Well, rate of change of momentum. Force is equal to change in momentum by time, right? So time is in the denominator. Force is equal to change in momentum by time. Time is in the denominator. When you are bringing a ball to rest, you are changing its momentum, right? If you give it more time, right, then delta p by t, change in momentum by time. If time is more, then the denominator is more. So force is less because force is change in momentum by time. If you are abruptly stopping the ball, that means you are giving it very less time to change its momentum. So time will be less. If time is less, time is in the denominator. So force will be more. So if you are giving it more time, less force is acting on your hands. If you are giving it less time, like means if you are abruptly catching it, it's giving more force on your hands. So that way your hands are likely to get more damaged. Very, very interesting question. Let's move on to the next question on the screen. This happens to be the final question. Which of the following laws is applicable when it comes to explaining how walking happens? Again, a very, very interesting take. A very, very interesting question. You will be understanding this in much more detail when you study Newton's laws of motion and friction in your class 11th. But in case some of you have already understood these laws fundamentally, you should be able to answer this. Again, it's a trap. Let me tell you this particular question. So read it carefully before you answer. Let's see how many will get this right. Okay, so the actual answer to this question is both option A and C. Yes, Newton's first law and third law. Let me explain you how walking happens first of all. So Newton's first law says a person or a body will start moving only if an external force is acted upon it. Otherwise, it will continue to be at rest for the rest of its life, right? So if I'm walking, that means I'm causing motion to myself, right? So somebody is applying force on me. That's why motion is happening, right? Newton's first law. Force must be applied on a body, only then it will move. I'm moving, so somebody is applying force on me. Who is applying force on me? The friction from the ground is applying force on me. That's why I'm moving. So Newton's first law comes into picture, right? But why is friction acting first of all? Because you're pushing the ground. Ground is giving a normal reaction, and friction will happen only if normal reaction exists. Listen to me again. You are pushing the ground is pushing you back. So the force with which ground pushes you back is known as normal reaction. That normal reaction causes friction, right? So without normal reaction, friction wouldn't have happened, right? So that way third law comes into picture as far as walking is concerned. So that's why both option A and C are right. So I hope you enjoyed this session. These questions were again original, and I hope you got something to learn, and that's how I'll come up with more and more original questions. In the beginning there were some hiccups, but yeah, we have just started. We are trying to look at our technical front, and we promise you as we progress we'll be more and more efficient in terms of how we conduct quizzes. I hope you guys continue to be with us and continue to have fun while learning. So yeah, thanks for joining in. That's all from